Hello students. In the previous period, we have seen the sphere of influence and the volume of a sphere of influence of molecule equals to the 8 times of the volume of the molecule. Now in this period we'll discuss the expression for mean free path. The mean free path of a gas molecule can be defined as the average distance traveled by a molecule between two successive collisions. We can calculate its value by considering the following assumptions. Assumption number 1, only the molecule under consideration is in motion and other molecules are at rest. Second assumption, the molecule have a sphere of influence around it and the radius of the sphere is equal to the diameter of the molecule as shown in the figure below. In other words, it means that the molecule can collide with only those molecules the center of which is at distance d or less. Now consider the molecule and let it move within the gas with a velocity c. As a molecule moves, its sphere of influence will also move. In 1 second, this sphere of influence will sweep out a cylinder of radius d and the length of the cylinder will be equal to the distance traveled by the molecule in 1 second. That is the velocity of the molecule as shown in the figure. That is velocity of molecule is equals to c, radius of cylinder is d and length of the cylinder is equals to c. Therefore, as the velocity of molecule and the length of the cylinder is same because molecule travels the distance of the cylinder. Therefore, volume of the cylinder is given by V equals to pi d square c. Let the number of molecules per unit volume be n. Then number of molecules in the cylinder is equal to pi d square cn. That is equals to the number of collisions per second. Therefore, average time between two successive collisions is equals to 1 upon pi d square n into c second. Hence, average distance between two successive collisions is equals to 1 upon pi d square n c into c. In this equation, this c will get cancelled and therefore mean free path equals to lambda equals to 1 upon pi d square n. This is equation number 3. If m is the mass of one molecule, then density is given by the equation rho is equals to m upon v. As 1 upon v equal to n, therefore rho is equals to m into n, that is the density of the gas. Therefore lambda is equals to m upon pi d square into mn, where in this equation we will put m into n equals to rho, that is the density. Therefore lambda equals to m upon pi d square into rho. This is equation number 4. Variation of mean free path with temperature and pressure. Scientist Ludwig Boltzmann obtained an expression for the mean free path by considering that all the molecules have same average speed. The Boltzmann's constant equals to k equals to p upon n into t, and also n equals to, only by rearranging above equation for n equals to p upon kt, where p is the pressure of a gas and t is the absolute temperature. Therefore lambda equals to 1 upon pi d square into n. Lambda equals to, putting the value n equals to, therefore n equals to p upon kt. Therefore lambda equals to kt upon pi d square into p. This is equation number 5. James Clerk Maxwell obtained the accurate equation for mean free path by considering the law of distribution, and it is given as lambda equals to 1 upon under root of 2 pi d square into n. Therefore lambda equals to, putting lambda equals to kt by p, Therefore, kt upon under root of 2 pi d square p. This is equation number 6. Thus, the mean free path is directly proportional to the absolute temperature T and inversely proportional to the pressure P, and it is given or written as lambda is directly proportional to T and inversely proportional to P. In this way, we have seen the sphere of influence and the expression for mean free path.